In this session of metrology and instrumentation, we will be discussing on classification of transducers. In this session, we will go into details about the concepts, classifications, and examples of transducers. Transducer is a device which transforms one form of signal to another form, typically a non-electrical physical signal such as temperature, sound, light, force, etc. are converted into electrical signals such as voltage, current, etc. Transducer is a device that is capable of converting the physical quantity into a proportional electrical quantity such as voltage and current. Transducers contain two parts that are closely related to each other, the sensing element and a transduction element. Sensing element is called as a sensor. It is a device that is producing measurable response to the change in physical signal. Whereas the transduction element converts the signal, output signal from the sensor to a suitable electrical signal. Take the case of a microphone, which is a very common example that we have seen even during our school days. In a microphone, the input is a sound. We have a diaphragm that will be sensing element. Diaphragm will be giving a vibration and that will be transferred to a coil and magnet, and that coil and magnet transduces this vibration to electrical signals. So this coil and magnet act as a transducer and the diaphragm acts as sensor. In fact, without a sensor, there is no transduction happens. Without transduction, there is no meaning for sensor also. So with the sensing and transduction are actually happening together. So the term sensors or transducers can be interchangeably used, and that is being used by even professionals. In this session, we will see certain classification of transducers such as analog and digital transducers, primary and secondary transducers. Transducers are inverse transducers, and the classification based on the transduction principle, active and passive transducers. Analog and digital transducers. Transducers, on the basis of nature of the output signal, can be classified into analog or digital transducers. Analog transducers means that will convert the output signal into the input signal into output signal, which is in a continuous function of time. It's a continuous output. Example, a thermistor which gives continuous voltage output. Strain gauge, that is also when there is a strain there can be change in resistance and there is continuous change in voltage. Thermocouple also like that. So these devices which are giving continuous output when continuous input are given. Whereas there is digital transducers that will convert the input signal into the output signal in the form of pulses, or it gives discrete outputs. An example is encoder, optical encoder. Optical encoder consists of a coded disc. It's a disc having certain openings and opaque regions, and the width of the opening and the opaque regions are equal. So these are equally spaced opening and closing. Now in this arrangement, there will be a stationary photodetector and a stationary light source such as LED. Now imagine that in a stationary situation of light source and the detector, if a shaft mounted with the encoder rotates, if the shaft rotates like this, the encoder will also rotate. When the encoder rotates, the light from this light source will intermittently falling on the detector whenever there is an opening coming against this light source and the detector. So whenever there is light falls on that, there is a pulse generated by the photodetector. When there is an opaque region, there is no light, so there is no output. So whenever there is an opening, there is an output. Whenever there is no opening, there is no output. So the output obtained from such an arrangement becomes digitized, either 1 here, or there is 0 here, 0 here. So such a output is called as a discrete output. An optical encoder is an example for a digital transducer. There are many other digital transducers. Even the analog transducers such as synchros and resolvers are also converting the output analog signal to digital signal for various reasons. Why digital signals are preferred? Because Digital transducers are more popular because of the advantages that the produced digital signals can be transmitted over a long distance without causing much distortion due to amplitude variation and phase shift. Storing and computation of signals are also easier. So, digital transducers are more preferred. Another classification is primary and secondary transducer. Transducers can be classified primary and secondary based on the method of application. Primary transducer, if the input signal sensed directly by the transducer is converted directly into the electrical form. An example, a thermistor, it senses the temperature directly and causes the change in temperature in the change in resistance, and that is an indication of the change in temperature. So, there is an output signal that is obtained in the electrical form and corresponding to the input signal directly. So, it is a primary transducer. Secondary transducers, in this, when the input signal is sensed initially by one sensor and then its output of some form or other form the other than the input signal is given as the input to the transducer for conversion into electrical form. That is, one form is converted to another form, then the second form is converted to electrical form. So, that is called as secondary transducer. An example is a pressure measurement with a Borden tube and LVDT, linearly variable differential transformer, LVDT. It is actually an electrical device where LVDT, there is a moving core, and the core is moving inside a coil. Then if the core moves, it's a magnet core that moves, then the coil will get an induced electrical signal, and the induced electrical signal is an indication of movement of the core. In Borden, if the Borden the pressure gauge, the tube is connected with the core, when there is a pressure in the gauge, the Borden tube will deflect. There is a displacement on the Borden gauge, and that deflection will cause the movement of the core, and finally you will get an electrical signal because of the movement of the core. So, the Borden tube is a primary sensor which converts pressure initially to displacement, then the displacement is converted to an output voltage by an LVDT. In this case, LVDT is a secondary transducer. Another kind of classification is inverse transducer and the common transducer. We know that transducer is a device that converts non-electrical quantity into an electrical quantity. Normally, a transducer and associated circuit has a non-electrical input and an electrical output. Examples are thermocouple, photoconductive cells, strain gauges, etc. You get output as electrical signals. Whereas inverse transducer, it is just opposite to that. That is a device that converts an electrical quantity into non-electrical quantity. Example, piezoelectric crystal, where we know that when pressure is applied, electrical charges are developed, and that if it is connected to a circuit, we can obtain the voltage difference. So, piezoelectric crystal, where there is pressure or applied pressure is the input, which is a non-electrical signal, and output is a charge, which is an electrical signal. Then the translational and angular moving coils inside the LVDT. We have seen in the previous case where there was a core that is moving inside a coil. Actually, the movement is a non-electrical signal, whereas the output obtained from the coil is an electrical signal. That is inverse transducer. Many feedback measuring systems, including the potentiometers or the synchros, etc., that utilize inverse transducing principle. Transducers can also be classified based on the transduction principle. That is, if a physical parameter that is sensed by the transducer is converted to resistance, then change in resistance, it is called as a resistive transducer. If it reflects in change in capacitance, it's capacitive transducers, like that. If it is possible that there can be voltage and current output generated because of transducer, that as we have seen in the case of piezoelectric device or in the case of LVDT. So, based on the transduction principle also we can classify transducers. Active and passive transducers. Transducers can also be classified based on the energy conversion. or the utilization of energy. Active transducers are transducers that develop output in the form of electrical voltage or current without any auxiliary source. These are also called as self-generating type of transducers. Normally, such transducers give very small output, and therefore they need to use amplifier along with the transducer in order to make it useful for application. We will give an example like piezoelectric crystals, where if a pressure is applied, the crystal will be generating charges, and the charges will be of the order of picocoulombs, 10 raised to minus 12. That is, even the case of a barium titanate, it develops around 250 picocoulombs only per Newton load. That means such a very small charge, if it is to be utilized for sensing purpose or any other application, the charge are to be amplified. So amplifiers are used along with the piezoelectric crystal. Same is the case with the thermocouples also, where the thermocouples use of measurement of temperature, where there is no electrical signal given. Because of the change in temperature at different junctions, it will develop voltage. So there is no signal given to this. So these are called as active transducers. Passive transducers, on the other hand, it will require external power signal for its functioning. This is called as passive transducers because in the absence of an external power source, these transducers are passive, and hence we call it as passive transducers. In passive transducers, electrical parameters such as resistance, inductance or capacitance changes with the change in input signal. In such transducers, electrical parameters, that is resistance, inductance or capacitance, causes a change in voltage, current or frequency of the input external power source. Examples for passive transducers are LVDT. We have learned LVDT, that will actually require electrical signal, and potentiometer is another device where signal is required to get an output. Active transducers, few examples are photovoltaic cells, thermoelectric transducers, electromagnetic devices, piezoelectric devices, etc., etc. For passive transducers, we have few examples like categorization, like variable resistance type, variable reactance, optoelectronic type of passive, etc., etc. Hall effect type is also an example for passive transducer. To remember a few, thermistor is passive, photoconductor is passive, and LVDT, variable reluctance devices, etc. are examples for passive transducers where we need to give external signal for its functioning. Strain gauge is also an example. Now it's time for a review. Please verify if you can classify transducers based on various aspects. Can you distinguish between null and deflection type transducers with one example each? Can you distinguish between active and passive transducer with suitable example? We have uploaded the learning material in the academic management system. Questions are also placed there. If you miss any of the content required for answering the question, you can please go to the learning material that is given in the platform. Thank you.